Polynomial division is a very useful tool for finding all the roots of more complicated polynomial functions. So things that are much bigger than quadratics or cubic equations. We're going to need to use polynomial division so that we can take out certain factors we can find easily and then have something simpler that we can solve. You know, maybe we can divide out enough factors so that we end up with a quadratic, which we can easily solve. So I'm going to go through the process of polynomial division. I'm going to use regular number division as kind of a template for what we're doing with polynomial division. So if you think back to when we were learning to divide numbers, what we would do is we'd ask ourselves, all right, I need to multiply this number by something that's going to, as closely as possible, match at least the beginning part of this number inside here. Well, I know if I multiply 3 by 4, I can get the 12. And then I would subtract it away to get 0. And then you bring the next term down. I would multiply that by 2 and get 6. Okay, subtract that away, which leaves me with 2. And then what this means is I've got 42 and 2/3, because I'm still dividing the 2 by 3. Okay, so this is my remainder part here. Now what this does for me is lets me know that I can rewrite 128 as 3 times 42 and 2/3. So we're going to follow those same steps that we did with numbers when we're dividing polynomials. So if they say divide this polynomial by this one, you're going to set it up. Okay, I'm dividing this, so that goes inside, by this one, so that goes outside. Now you're going to ask yourself, what do I multiply this by so that I can, as closely as possible, match at least the first part of what's inside here? Well, if I want to match the first part of this, I'm going to multiply by 2x squared. Okay, so I'm going to multiply 2x squared by this whole polynomial here. So when I do that, I get 2x to the 4th plus 4x cubed minus 6x squared. And if you remember, after we put it underneath there, we subtracted it away. So I'm going to subtract this. So the easiest way to subtract is to just change all your signs and then think of it as adding. So these cancel and go away. These cancel and go away. This leaves me with x squared plus 3x minus 2. Now, what can I multiply this by to match the first thing? Well, I could multiply by 1. So I'm going to add that 1 on. Every time you do another multiplication, you're going to add what you're multiplying by. So to multiply it, okay, so that gives me x squared plus 2x minus 3. And then I'm subtracting, so I'm going to just change all my signs. Okay, that way I don't forget. And then I'm going to add these up, so these go away. This turns to just x, and this turns to plus 1. Now, I can't make this match this, because my power is too big here. So this becomes my fractional remainder. So I'm going to add my remainder over my divisor. Okay, and this is your answer. This is what you get. So let's look at one that doesn't end up with a remainder. Okay, so like I'm going to compare this to like if we had 126 divided by 3. Okay, so here we would get a perfect answer with no remainder, which means I could factor 126 into 3 times 42. So if we're dividing here, first I need to match the 3x to the 5th. So I'm going to multiply by 3x to the 3rd. Okay, multiply that in here. So that gives me 3x to the 5th minus 6x to the 4th plus 3x to the 3rd. Now make sure that you're always lining up. You want to subtract 5th powers of x from 5th powers of x, because sometimes these will skip and you'll end up with holes that you want to match up. So, you know, I wouldn't want to put 3x to the 3rd underneath an x to the fourth. I want to make sure it's underneath the other x to the third. So I'm going to subtract. Okay, and this is going to cancel here. This is going to leave negative x to the fourth. And this is going to be negative 25x cubed. Okay, I've got 3 terms here, so I'm going to bring one more down. I always want to have at least as many terms as I have over there. To match this, I'm going to have to multiply by negative x squared. So we get negative x fourth plus 2x to the third minus x squared. Okay, now I'm going to subtract this, so change all my signs. So here that goes away. This is with negative 27x cubed, and this would be plus 63x squared. Drop the 45 down. Okay, I'm going to have to multiply by negative 27x. Okay, which is going to be positive 54x squared and negative 27x. Okay, change all my signs again. So that becomes plus, this is minus, that's plus. Those go away. This would end up being 9x squared. And this would turn out to be negative, let's see, 18. And then bring the plus 9 down from up top. Now to match this, I'm just going to multiply by a positive 9. And I get the exact same thing that I have. So when I subtract these away, I get no remainder. So what this would allow me to do is rewrite this big, long polynomial as the product of these two. Okay, and so what we're kind of working towards is instead of having this thing, which we can't solve, okay, I can't like set this equal to 0 and figure out a way to factor or anything like this. So this is a method of factoring. If I can figure out something that can come out of here, I can get in these two factors and set each factor equal to 0 and kind of get zeros from each piece, right? Because I could get zeros from this one, okay, because it's quadratic. And I could actually factor this one. So we actually have one that we could finish off here. I could factor this and do x minus 1 and x minus 1. Okay. This one I could factor by grouping. Okay, so I can see that I can pull an x squared out of here and leave 3x minus 1. And out of the next two I can pull out a negative 9, which leaves me with 3x minus 1. So this turns into 3x minus 1 times x squared minus 9. And of course the x squared minus 9 will break down again. So now I've got this. So now I can see exactly what my zeros are going to be. I could set each parenthesis equal to 0. So I set this one equal to 0, I get x equals 1. I get the same thing here. Here I would get x equals 1/3. Here I would get negative 3. And here I would get positive 3. So I've just found all of the zeros or x-intercepts of this equation. And that's kind of what we're going to be working towards. Right now we're just working on the prerequisite skill in order to be able to do that. Sometimes you might have repeated division. So that just means we're going to divide by this thing twice. So you've got two choices. You could multiply your denominator out here. Okay, rewrite it as x squared minus 4x plus 4 and divide this thing by that. Or you could just divide it by this smaller one twice. So I'll kind of go through the twice one so you know how that works. So I'm going to divide by one of them. Okay, I'm taking one of the two that I have down there and dividing. So I need 2x squared here Okay, subtract. I'm going to change my signs. That cancels. This turns to negative 3x squared. Drop the 4x down. Okay, now I need to multiply by negative 3x. Okay, change my signs. Add them up. This goes away. This was plus, so now it's minus. So that leaves me negative 2x plus the 4. So I need to multiply by negative 2. Okay, and I get no remainder. So now when I go to divide by the next one, I'm not going to divide this. I'm going to divide my answer by this. Okay, this would compare to dividing 16 divided by 2 squared. Okay, and instead of squaring this out, we're taking 16 divided by 2 to get 8, and then dividing by 2 again to get 4. That's kind of what we're doing. So we're taking our answer and dividing by the other divisor. So I'm going to take my answer to that one. Oh, it's a squared. And dividing by the other one that I didn't use yet. So I need 2x here. Subtract these. That goes away. This leaves x minus 2. And of course that goes in there once, leaving me no remainder. Okay, so that means I can turn this into a factored form. Okay, and this is the same as this. Okay, and you should be able to check that answer by just multiplying back to get that. So that's the end of repeated division. I guess it's a good thing since my airliner battery's starting to die.